Hi everyone, welcome. I am Prasanna Kumar S, working as a technical marketing engineer in IP Infusion. Today we will go through the EVPN-VxLAN demo of the part 2. So you'll see the EVPN functionality in OcNOS. Last time we have seen this class fabric and we have demonstrated how to configure using unnumbered interfaces, BGP peer groups, and how do we do with different VLANs into the same VPN. And we have also seen multi-homing configurations. Okay, as part of the demo part 2, today we'll understand how ARP cache works in OcNOS in the EVPN-VxLAN fabric, and similarly ND cache, how it works, and how MAC movement works. We will be seeing as part of this demo. Let us see the topology. Okay, to check the ARP-ND configurations, first we will be learning the ARP from the leaf 3 perspective, and then we will see the entries in leaf 1 and leaf 2. All right, so whether we are learning the remote ARP or not. And in the next part, we will be sending ARP request from the switch behind the multi-homing, right? So then we will try to see that, whether it is locally responding or not. Let us get into the boards. Let us verify the ARP entries. So in the leaf 3, we can see that there are no ARP entries. Similarly, in the leaf 1, let's check it again. So here also there are no. So in the leaf 2 also, we don't find any entries. Let us send the traffic and learn one ARP. From IXIA 1/9, we are going to generate the ARP request here. We are in the IXIA now. This is the 1/9. Let's send one ARP request over here. We have sent an ARP request. Let us verify the ARP entry in leaf 3. So here it is showing that dynamically we have learned the ARP address. Similarly, we can check in leaf 1 and leaf 2. So in the leaf 1, we have got a log saying that it has learned from remote. So we'll see that it's a dynamic remote. Corresponding log has come. Similarly, in the leaf 2, we would be able to see the ARP entry. Before we really check about ARP cache, so let's clear the counters on the VxLAN access IF so that now we are ready for the test. So I'm clearing the counters in all the leaves. So now I'm in IXIA. So we are going to send ARP requests. It has started. So now we are sending ARP requests from here to both the nodes. So one of the node will get it because there's only one stream we are sending. Now let us check the counters. So I'm in leaf 2 now. So the PO is receiving 10 packets and it is also sending the 10 responses. So we don't see any other packets over here in this topology because we are not sending out anything. Okay. And similarly, if we verify, so we can see that the requests are coming and the responses are going back. Okay, so this proves that it is locally responding, and on the physical interfaces we don't see any other packets going out. So this demonstrates that the R cache is working, right? So since we are generating the R request, so that would also be learned as a local. Here in this counters, we should observe that we have received Rx of VxLAN R request, and this is the Tx actually what is happened. Similarly, let's check the ND cache also. We don't have any entries now. Similar to the earlier methodology, we will send out one ND request over here, and we'll try to see that it's a remote over these two leaves, and then we will try to send ND stream, and then we'll try to verify that it's really working. I'm in Nixia now. From the same port, I'll trigger an neighbor solicitation over here. So this will make an entry over there. Let's check it in the leaf 3. Yeah, this is learned now because we triggered a request. Similarly, we will see that in the leaf 2, we have learned it as a dynamic remote. And in the leaf 1, also, we should have it as a remote. Okay. So this is now populated the entries. Now let's send the traffic and ND traffic, and then see that it is locally responded. So we are in Ixia now. So we will generate the ND NS request to the multi-homing group. So now we are in the leaf 1. Again, let's check. Okay, so the ND learned, the earlier 400E was there. So now 1010 has been learned as a remote. Probably it might have learned in another leaf. Let's check. So we're in the leaf 2. So we see that, this is learned as local over here. And let us verify the counters. So here we are receiving the 10 request packets, and we are sending back the 10 response packets. Right, so let's verify the access port counters. We can see that, so the Rx we have received 717, and we have responded with the responses of neighbor advertisement. Okay, so this confirms the ND cache as well. And in the leaf 2, we can see that the remote entry has been populated along with the local, which was learned originally. So this confirms the ND functionality. So now let us move to the MAC-move scenario. To demonstrate the MAC-move, in the original topology, we have introduced leaf 4. Okay. So the leaf 4 connected Ixia will act as a source of the traffic, and it will be sending the traffic towards host behind leaf 3 or this particular MH group. So we will try to move the MAC from 113 to 19 or 19 to 113, and we will see that how the MAC movement is happening, and accordingly how the traffic is steering towards the MAC where it has been learned. Now we are in the Ixia. Let's start the traffic. We have started the traffic. Let's see. Yeah. So on both 1/9 and 1/13, this particular traffic has been received. Okay, because the MAC has not been learned. So now let us learn the MAC address. So now the traffic has been received by 113 as well as 1/9 because both of the MAC has not been learned. So now let us learn the MAC over 1/13. Okay, so we are going to do this 1/13, start the traffic over here. Okay, now let's verify it's going to happen. So now 113 is continuously receiving it, and here it would have stopped incrementing. So if we clear the stats, yeah. So we can see that 1/9 stopped receiving the traffic, and 1/13 it is receiving the traffic properly. Let us verify the MAC table once. Let us verify the MAC table in leaf 1. So we have learned the MAC over here in leaf 2. So here it is showing as a remote. So now let us do the MAC move once to the other port. Now the traffic is coming towards 113. Let's start the, let's move this MAC to the 1/9. Now we are in Ixia, so we will stop this 1/13. Okay. Then we will move it to 1/9. So let's see what is happening. So we are getting a MAC mobility event. Okay. So it's also showing the sequence number. So now we can see that, the MAC has been moved. Okay. So I'm checking in leaf 2. So let's check in the leaf 3. So here it has learned because we sent it from 1/9. So hence this has been local and the MAC move count is 1. So now the MAC is here. So now again we will try to move it to back to 1/13 and see that it is happening properly. It was here, the traffic MAC was. So the traffic was taking this path. And then now we will move the MAC back to the 1/13 and we'll see what will happen. Yeah, before moving to 1/13, so we could see that the 1/9 is actually receiving the traffic. Let's move. We have enabled the logging just to showcase that it is more convincing to showcase. So now we can see that the MAC has moved from local to remote, and it is showing that the MAC count is 2. So just see what has happened before, right? It was local. So it was local with the VTEP IP, and now it is with the remote with the ESI. So now the MAC has been moved over there. Let's go to the leaf 1 and leaf 2. So here earlier it was showing dynamic remote. So now it's still showing dynamic remote, but the counter is incremented. Let's see whether it has learned in leaf one. Yes. So here it is learned in the VTEP one. So it is showing as a dynamic local, but it has moved. So now let's verify the IXIA traffic. So in the IXIA, we could see that whatever we have sent it from 1/14, it is received only on 1/13, but 1/9, it is 0. Let's quickly do one more time. We can see that whatever we have sent from 1/14, it is received on 1/19. Okay, but on the 1/13, it is 0. So as wherever the MAC moves, so similarly, the traffic will move to that particular destination. So let us check the MAC sequence number. So it has changed. So as and whenever we move the MAC addresses, so this will be keep moving. Okay, so this completes the demo for today, which we have seen R cache, ND cache, and MAC mode. So in the next video, we will try to cover the IRB part of EVPN using VXLAN. So thank you. Have a nice day. Bye-bye.